Dear students, welcome back to Explore Electronics. Here let us see the solution to VTU question paper for the subject Digital System Design using Verilog. So you can see here this is the exam held in January-February 2023. So let us get into the questions. What are combinational circuits? Give example. Explain combinational circuit with a block diagram. Here first you need to write the block diagram of the combinational circuit, and also you need to write the definition first. Combinational circuits are a type of digital logic circuits that produce the output based on the current inputs. This is very important here. The output based on the current input combination. The output of a combinational circuit is not affected by past state, means the previous state of the inputs. So whatever the inputs we are going to give, for these inputs the combinational circuit will generate the outputs. This is the block diagram you need to write. Explain combinational circuit with a block diagram they have asked. So we have written the block diagram, and n number of input variables will be there, m output variables will be there, and at the instance of time the output will be generated depending on the present inputs. These are the things you can explain. Better to write examples over here. They have not asked the examples to write, but it's good to write the example so that you will get maximum marks. So adder, encoder, decoder, mux, demux are the examples for combinational circuits. And remember, combinational circuits will not be having a clock signal. So this is what it is given in the scheme. You will be getting 1 marks if you write the definition, and if you write examples you will get 1 marks for this combinational circuit diagram. And here they have just given the expression. This is not required, you can write it. This gives 1 marks. Block diagram and explanation is 1 marks. Define canonical form representation and solve the following equation using canonical form. So the two expressions are given. So since this is for 8 marks, it will be divided into 4 marks and 4 marks. By taking this expression, we need to write the canonical form. So first define the canonical form. So write the explanation. What is canonical form? It is a switching equation or logical expression in which each term should contain all available variables. Means in the first expression we have a, b and c, means this is the function containing a, b and c. So every expression should be having a, b and c components or variables. So here a, b bar is there, here c is missing, so we need to add c like this, a into b bar into c plus c bar. Similarly here a into c bar is there, with that b is missing, so we need to add b. Similarly here we need to add a, and then solve this. Here these two expressions are same. We know that a plus a will be equal to a. By using this rule we can replace these two with a single expression, a, b bar, c bar. And now if we take these into values, 5, 4, 6, 7, 3 is the values we are going to get for these minterms. Similarly for the second expression, w bar x plus yz bar is given. Here we have w, x, yz, 4 variables. So for this we need to add y plus y bar and z plus z bar. For this we need to add up with w plus w bar, x plus x bar. First I am going to multiply this with the expression and then keeping this as it is. Similarly multiplying this with this, keeping this as it is. Again multiply this, you will get this expression finally. Here also this one and this one are repeated. Again we need to use the same rule, a plus a gives a only. So twice 6 is there, I am going to write only once. This is the result. Simplify the following Boolean function using k-map. Here this is a 3 variable expression, we need to use 3 variable k-map. X, y, z is given. So you can take z over here or x over here and 2 variables over here, and you can write. So carefully group this, it will give you the result z bar. And the second expression ABC, you will be having these values. If you group together it gives a bar c plus b. I have a separate video on this in detail. I have explained how to use the k-map and fill the variables and how to group and get the expression. Please visit that and then you will understand clearly. Define k-map, solve the following expression using k-map. Again, this is also a k-map question. but this is 4 variable. In the previous question, it is for 8 marks. It is 4 marks and 4 marks question, since it is 3 variable K-map. Here you can see it is 4 variable K-map. So this will be for 5 marks, this will be for 5 marks. Then you need to define the K-map first. K-map is Karnaugh map, is a visual method for simplifying the Boolean algebra expressions. And also it is called as a graphical representation used in digital logic or system design to minimize the logic and simplify the Boolean algebra expressions. So this is the function they have given, and we have taken wx as well as yz and grouping here. Finally it leads to w bar y bar plus wz. Solve this by yourself, and you can visit the video of 4 variable K-map in my playlist, and you can understand if you have any doubt. And similarly, the next expression given ABCD is summation m this, and you can do this by your own. Here grouping is given, and the answer is C bar D bar B bar plus A bar plus D B bar. Then the next question, define Quine-Maklowski method and solve the following Boolean expression using Quine-Maklowski method. So here definition carries 1 marks. Here I forgot to put the definition. Please write the definition, what it is, why the Quine-Maklowski method is used to solve the expressions again by using the method. So similarly here the 2 expressions are given. This is for 5 marks. This solution is for 5 marks. Here you can see briefly given the description. I have taken this from the scheme of evaluation. That's why there is no full detailed solution not given over here. Try to solve this, otherwise I will do this in a separate video. There we can discuss the complete solution. So try to get this expression. If it is wrong or you will get the correct expression, please comment below if it is wrong. Similarly, the second one, k is equal to f of wxyz is solved over here. This gives x bar z plus wz. You can see here how the marks will be divided. This carries 2 marks, this carries 2 marks, and then the final expression carries half marks. Explain binary adder with K-map and logical representation of equations for sum and carry. Here they simply asked explain binary adders. So you can explain full adder, half adder. So better explain what is half adder and what is full adder. Half adder is one, it will add only single bit 2 variables and are 2 binary numbers. Full adder is that it will add 3 variables like A, B and C. Half adder will add only 2 single bit variables. Like that you can write, and it gives sum as well as carry as output. And then you can write the truth table. Use K-map method, since here they have asked K-map. Use the K-map for simplification of sum as well as carry. Here you can see this is the truth table for the full adder. This is for full adder, and I have used the K-map to get the expression for sum and also for the carry out. Here is carry out and this is sum. And also, since they have asked the adder simply, they have not mentioned only full adder, half adder like that. Better to write the ripple carry adder. This is ripple carry adder circuit. Just write the circuit. And one more thing is that write the gate level circuit for sum as well as carry. Then the next question, explain carry look ahead adder with general and sigma block. So carry look ahead adder, I will show you in detail. This is the carry look ahead adder block diagram. This will take A0 B0 into one full adder, A1 B1 into other full adder, A2 B2, A3 B3 separately. This is a 4-bit carry look ahead adder. And there is a carry look ahead block. It will generate the carries. You can see C1 is generating from the carry look ahead block going to the next one, C2, C3. By using P and G signals, this C will be generated. You can see here, this is generate signal, that is G0, G1, G2, G3. Similarly, kill signal is there, that is not required here, not shown, and P signal is there. A into B gives the generate, and propagate will be A plus of P, means that is XOR. So you can write these expressions, and also you can write this diagram. It clearly gives you how the sum of each bits are going to be calculated. And C1, C2, C3 and C4 expressions you need to write. These two diagrams is mandatory for this question. Explain working of decimal adder with neat block diagram. Take example of BCD addition. They have given here, you need to take the BCD addition as example. Take BCD adder as example and write this question since they have mentioned it. Otherwise you can take any adder for adding the decimal numbers, you can write. So here in the scheme they have splitted marks like this. This is the general block diagram of the decimal adder by taking A and B together, and this gives sum and this gives C out, and C in is the input. What are comparator circuits? And explain 2-bit magnitude comparator. Comparator is a logic circuit that compares the two binary inputs. If the two binary numbers are given, that will be compared and give the result as whether it is lesser, greater, equal compared to the other number. So here is the 2-bit comparator truth table. For that we have A greater than B, A equal to B, A less than B as outputs. For those we have generated the expressions over here, and using those expressions we need to write this diagram. So this much carries 8 marks. So usually 2 marks for the truth table, definition carries 1 marks, and these solution carry 3 marks, 3, 4, 5, 6, and 2 marks will be for the circuit. Realize the Boolean expression using 3:8 decoder and 2 OR gates. So better to write the truth table of 3:8 decoder. Here I have not given. Write the truth table and then take the function and implement it using 3:8 decoder. 3:8 decoder implementation is also available in the playlist as a separate video. Visit that and understand completely how you can easily do the implementation using the decoder. So here the 3 inputs you can say x0, x1 and x2. Using the decoder and 8 at the outputs, since it is 3:8 decoder, 8 outputs will be there. 1, 2, 4, 5 is the expression, first expression consisting of. So 1, 2, 4, 5, take these into one OR gate, that gives the function easily. Similarly 1, 5, 7 in the second function, take 1 again 5 as well as 7 into the second OR gate, that gives F2. So here here this should be connected to 1, this should be connected to 5, and this should be connected to 7. Implement D is equal to W x comma y comma z function using 8:1 marks. So here implementation table carries 3 marks and logic diagram carries 3 marks. Here I have given the detailed explanation. Write the truth table and the function, and here I am going to write the minterms where they have given it as 1 and the remaining things are 0, and later so fill these with zeros and ones as per the function given, and we need to group 2 together, since this is my W x y is my, this is W, this is x and this is y. These are my select lines. Since these are select lines, z becomes the input. This is z, not d. Okay, now this is also z, this is also z. So I naught will be 0, 0 is there, 0, 1, 1 is there. It means z will be the output when the select line is 0, 0, 0 for I naught. So we need to give z over here. Similarly, I1 is 1. So this I1 should be connected to 1. Similarly, I1, I2, I4, I6, you can see these are generating 1. So the input will be 1. Similarly, you can see other I5 and I7 is 0 and I6 is 1 connected. So this is how you can solve the implementation using 8:1 marks. There is a separate video on this also. You can visit that for clarity. Write a note on master-slave JK flip-flops with function table and timing diagram. Here first we need to write the master-slave flip-flop diagram And write a note means you need to write the explanation. Don't miss to write the explanation. If you skip writing the explanation, writing only this much gives you only 5 to 6 marks. So block diagram, and what is master slave flip-flop? There will be a master flip-flop and there will be a slave flip-flop. The slave flip-flop will get the input from the master flip-flop. The output of master will be an input for the slave. This is what you need to explain first, and then write the JK flip-flop implementation. Then write the function table and also the timing diagram. In timing diagram, you need to mention how QM or this QN will be generated clearly. What are edge triggered flip-flops? Explain positive edge triggered and negative edge triggered flip-flops. First, write what is positive edge and what is negative edge. Positive edge in the sense in the clock signal when it is going from 0 to 1. Negative edge in the sense when it is going from 1 to 0. You need to first indicate that, and this is what the edge means. After that, the output is going to be changed with respect to the clock edge. If it is a positive edge flip-flop, the output is going to be changed only when there is a positive edge occurs and flip-flop is sensitive to that. And only at the edge, the sensitivity of the flip-flop fetches the input and sends it and gives the output. So this much you need to write. Similarly, for the positive edge, mention it will sense at the positive edge of the clock signal. For the negative edge, mention it will sense the input at the negative edge of the clock. So this is the block diagram. If you can write any complete circuit using positive edge and negative edge, and also the waveform, that gives you complete marks. Try to write the waveform for D flip-flop since it is simple. Write characteristic equation for JK flip-flop and SR flip-flop. Write the characteristic table JKQ, and Q plus 1 is the next state. So write the expression for Q plus 1 using K-map simplification. So here JQ bar plus K bar Q is the characteristic equation we are going to get for the JK flip-flop. Similarly, for SR flip-flop, write the characteristic table, put it into K-map, it will generate you the expression. Define counters, explain binary ripple counter with neat diagram. Here, first you need to define counter. What is binary counter? It is a circuit that counts the binary numbers. It is a hardware circuit made up of flip-flops or registers with output of one flip-flop sent to the input of the next flip-flop. Here is the state table you can see, and also the truth table. You need to write full truth table. Don't write like this. You need to write the full truth table. You need to write the waveform and explanation. This carries 2 plus 2 marks. Truth table carries 2 marks. State table carries 2 marks. Here is the complete truth table. This is the count. Previous state, if you take it as 0000, and the next state will be 0001. My input for the flip-flops D should be this. So this is how you can take, since I am taking D flip-flop, that's why I am taking these values. You can take JK flip-flop and implement also as shown over here. So this is how the state table will be for all the states 0 to 15. I have taken 4-bit counter here, and then correspondingly by looking at this, the next state D inputs and all, you can generate what is the value of D3, D2, D1 and D0 should be, and you can connect these in a diagram like this, so that this is the implementation of a counter using D flip-flop. You can use any flip-flop and design the counter. There is a separate video on this also. You can refer that for the more information. What are registers? Explain any two classification registers with neat block diagram. Register is a small storage space in a computer processor that stores data instruction for quick processing. So registers are made up of multiple flip-flops. This is what the answer expected from you in exam. Registers are, in the sense, it is flip-flops, multiple flip-flops connected together. Then, which are electronic circuits to store a single bit of information. So here the first line is the general term with respect to computer architecture is concerned. This second line is with respect to the subject is concerned. They are expecting it contains flip-flops. This definition carries 1 marks. you can explain parallel in parallel out or serial in serial out or serial in parallel out. They have asked to write 2. So this is the block diagram. You can see parallel in parallel out in the sense, if you have a multiple flip-flops like this, parallelly you need to give the inputs, means 4 inputs, like this is A3, A2, A1, A0, and parallelly we need to take the output. In one clock cycle, all the things, means clock signal will be common for all these. So this is clock. Whenever the clock positive edge comes, all the flip-flops are going to give you the output at a time. That is parallel in parallel out. Similarly, serial in serial out is there. Serially, this parallel inputs will be not there. Serially, we need to give the inputs. This will be transferred to this, this will be transferred to this, this will be transferred to this. Finally, the output will be getting over here. You can see at the last, we are going to get the output. From first, we need to give the input. For every clock edge, the transition is going to happen. This is serial in serial out. Serial in parallel out. So here, serially input is going to be given from one flip-flop, and parallelly we are going to take the output of those from each and every flip-flop. So this much you need to explain by taking 2 such examples. Design synchronous mod 6 counter using clocked JK flip-flop for sequences. Here the sequence is given. So the given sequence becomes the present state. 0, 2, 3, 6, then 5, then 1. This is the present state. You know what will be the next state. When this is the present state, this is our next state. This is present state, this is next state. So 2 we need to write here. So present state becomes 2 now, next state is 3. Now by taking this into the JK flip-flops, we need to implement using JK flip-flops. So we need to generate what is J and K inputs are. By simplifying this in a K map, we will be getting these expressions. Finally write the circuit using JK flip-flop. Define HDL and type of HDL. Give structure of Verilog module with an example. First we need to write the definition, structure of Verilog, and then any example carries 3 marks. Let us see. First, what is HDL? HDL means hardware description language. It is a programming language used to describe behavior or structure of a digital circuit. HDL are used to simulate the circuit and check its response. There are 2 types of HDL which are popular, VSDL and Verilog. Here is the Verilog module. It consists of module, statement and a name, then port list, then parameter list if it is there. Similarly, port list if it is available. Then we are going to declare wires and registers if it is there. Then data flow statements with assign keyword and instantiation of lower modules can be there. Always initial blocks can be there and other behavioral statements can be there. If it is there, task and functions we are going to write. Finally, end module. So by writing this, you need to explain this much. Then any example. Here I have taken half order example, and here also better to write the truth table. So this much you need to write for this question. Explain Verilog logical operators with example. Logical operators are and, or, not, like this. So with example means you need to take any values like this and evaluate this, and you need to tell the result what it gives. So these are logical operations. Then write a note on Verilog data types. Data types are wire type, register type, int type, array type, parameter type, and processor, preprocessor, directive type. And here also you need to declare a wire register in a module as example, and you can write a simple code simply declaring these without writing any logic. That fetches you complete marks. Write a Verilog code for 8:1 marks. So 8:1 marks is this, the block diagram. Here truth table is missing, you need to write the truth table for this, and this is the complete Verilog code for 8:1 marks. Here I have used case statement. Better to use the case statement while writing the marks if they have not mentioned a particular one. If they generally ask to write the marks, write using case statement or assign statement like that. Give classification of types or styles of description in Verilog with example. There are 3 types of description: data flow, behavioral type, structural type. So here I have taken an example of 4:1 multiplexer. Using gate level description I have written the code, and also using data flow description I have written the code, and also using behavioral description I have written the code. So with example, if they ask, you need to give the example for all these three. That's why a common example is taken and it is written in all the three styles. Here gate level description, it means a structural description sometimes. So these are the structures we have connected together. Write a Verilog code for full adder. So this is the full adder truth table, full adder logical circuit, and write the Verilog code for full adder. Here also they have not mentioned which description you are supposed to use. That's why I am using data flow description, since it is simple. So in the data flow description, we are going to use the expressions directly with an assigned keyword. So it is easy to write. Write a note on arithmetic, shift, rotate, relational operators with example. So these are also a Verilog operators. You can see one Verilog operators question will be there in exam, since it is very important thing of Verilog. So here is the Verilog arithmetic operators, relational operators, and shift operators. You can also write a simple code or by taking an example of values for a and b, and you can solve this, what gives a plus b, a minus b, a less than b, a greater than b, and shifting and arithmetic shift. Write a note on structure of behavioral description with example. Structure of behavioral description in the sense, it consists of a sequential statements, it consists of if-else case statements, it consists of loops like while loop, for loops, and we can have tasks and functions. Like this you can write as a description, and here the output will be always depend on the or within the always or initial blocks will be used. So these are the things you need to write within with respect to behavioral description. Behavioral description means there will be an always block, there will be an initial block, or any of these. That is what the expected answer is. And with an example they have asked, so write any code using behavioral description. I have used the 4:1 code here. Why? Because previously in the other answer I have written the same code, since it is easy to write that. Write a note on signal assignment and variable assignment with example. So you can see the execution of signal assignment statement by taking these two statements. Here the delay is given, and when the delay is given and I1, I2 are the inputs, how it will be assigned to the output 1 and output 2 with a delay. This is what explained over here. This is signal assignment. For a signal, any delay is given within a always statement. How the delay will be taken and it will be executed is explained by taking an example. This is the answer for signal assignment. This variable assignment is a question of VHDL. I don't know why they have given over here. Since you know the variable assignment with an example, you can write that with some simple explanation. Otherwise this question will be not included, it should not be included over here. Write a note on sequential statement with example. So sequential statements are in behavioral description, you know, we can use if-else statement, we can use for loop, we can use case statement. Sequential statements are if, else, else if statements. So first you need to write the syntax for if-else formats. If statement, how we are going to use. If you use else, how it will be. If you use if-else, how it will be. Then give an example for this also. Write any simple Verilog code using if-else for a 2:1 mux or 4:1 mux encoder, something like that, or a half adder, something like that. And you need to explain how these statements are going to be useful. These are going to check the condition. If that condition satisfies, this will be executed. Else, the other statements, set of statements will be executed like this. Write a Verilog code for 2:1 mux using if-else statement. See here, for the previous question also, if you are going to write if-else, you can use this as example. So 2:1 mux Verilog code we need to write using if-else means first declare inputs. Here the first thing is that you need to write the block diagram, you need to write the truth table. For any code you are going to write, first you need to write these two, and then output register. Remember, whatever the output variable you are going to declare, register that as a reg in behavioral description. Always at d in 0, d in 1 and select line. When select line is 0, d0 will be selected as output. When select line is 1, d1 will be selected as output. Explain structural description with example. Here structural description with example they have asked. Structural description in the sense our design should contain the lower modules and we need to instantiate those. So this is the instantiation of half adder to get full adder. So I have taken full adder design using two half adders. This is the diagram, and here first half adder code I have written, and using that I am writing the full adder. This gives 2 marks for this, 2 marks for this and 4 marks for this. Explain structural description of 3-bit triple carry adder. So first write the simple notation how the calculation of 3-bit adder will be, and for these 3 we need to have 3 full adders that explain, like full adder 0, full adder 1 and full adder 2 requires over here, and the carry will be propagated to the next stage once the sum of this will be generated from the previous adder, like that. And you need to write the Verilog code. Explain structural description of 3-bit triple carry adder, means it is a Verilog code. So again write a full adder here, use that full adder to get the ripple carry adder. This is what the answers for the question paper of DSDV, and DSDV playlist is available over here. Please visit that playlist. You will get the detailed explanation for these concepts. Thank you.